Alright, so what we're going to do is we are going to look at how to factor a quadratic equation. So basically, anytime I factor a number, say I wanted to factor the number 6. Well, my goal is to find the numbers that multiply to give me 6, right? So, 2 times 3, 6 times 1, and so on. But what I want to do here is I want to factor a quadratic. So in this case, let's look at 6x squared plus 7x plus 2. This is my quadratic. This is what I'm trying to factor. So basically what I'm trying to do is find two binomials that when I multiply them together, I get this quadratic. So what we're going to use first is what's called the box method. It's essentially reverse distribution or reverse distributive property. The way we set this up is we draw a box with 4 sections in there. The first term of our quadratic goes in the top left box. The last term of our quadratic goes in the bottom right box. This is just to help us to organize our thoughts and to figure out what numbers we need to use to factor. So the first step in figuring out what goes into these two boxes is to multiply the first box times the last box. So 6x squared times 2 gives me 12x squared. The reason why I'm going to do this is that the first and the last box have to multiply to the same number as the second and the third box. So these on the diagonals have to multiply to the same number. Now my second clue for finding the two numbers for those boxes is to look at this center number right here, the 7x. So these two numbers have to multiply to give me 12x squared, and they have to add to give me the center number, 7x. So here I need two numbers that add to 7x and multiply to 12x squared. Now, if you think about it for a second, the two numbers that fit that would be 3x and 4x. 3x plus 4x gives me 7x. 3x times 4x gives me 12x squared. So that means these are the correct two numbers for the empty boxes. Once you get your box filled in, what you're going to do is you're going to find the greatest common factor for each row and each column. My suggestion is to always start with the x's first, so this first column and the first row. It helps us with our signs later on. So in this case, I need to find the greatest common factor for 6x squared and 4x. I'm going to look at the numbers first. The biggest number that I can divide 6 and 4 by evenly is going to be 2. I'm not quite done yet though. Notice I have an x squared here and an x here. That means I can factor an x out of both of them, so I need to put that up here also. Okay, now let's factor the first row. 6x squared and 3x. The greatest common factor of 6 and 3 is going to be 3, and the greatest common factor of x squared and x is x. Now let's look at our last row and our last column. The greatest common factor of 3x and 2. Well, there aren't any x's that I can take out of both of them. This one has an x, but this one doesn't. So there aren't going to be any x's in this part up here. Now let's look at the numbers. We got 3 and a 2. The only factor that they share in common is a 1. So I'm going to put a 1 up here. Let's look at this bottom row. 4x and 2. Again, there's only an x in this term, so we can't pull an x out of both. Now we need to look at the numbers. We got 4 and 2. Well, both of these are evenly divisible by 2, so that means that 2 is my greatest common factor for that row. Now all I have to do is write down my two binomials. And if I look at this top part, this is actually going to give me one of my binomials, 2x plus 1. So that's half of my answer, 2x plus 1. Now to get the other half, I just look at the vertical part here, 3x plus 2. So that's my other binomial, 3x plus 2. Now I've found the two things that when I multiply them together, they give me 6x squared plus 7x plus 2. If I check this back, I get 2x times 3x, that's 6x squared. And then I'm basically doing the FOIL method here. So that was the first terms. The outside terms, 2x times 2 gives me plus 4x. The inside terms, that's 3x plus 1, gives me 3x. And the last terms, 1 times 2 gives me 2. Then if I combine like terms, 6x squared plus 7x plus 2. So I did indeed find the correct factors for this quadratic.